This is a Math 2 summary video for the lesson titled Taking Apart the Area. The purpose of this task is for students to factor quadratic expressions. This task reviews the work students completed when they studied quadratic expressions in Math 1. In this lesson, students will continue to use the box method to factor and relate the dimensions and area of a rectangle to the factored and expanded forms of a quadratic expression. Let's start by reviewing the steps for factoring any quadratic expression written in standard form. First, look for greatest common factor. If there is a greatest common factor other than 1, factor out your greatest common factor. Then, multiply a times c and find two numbers that multiply to get the product ac and add together to get the sum of b. The two numbers that you find will be used to replace b in your expression. Now fill out your box. The two numbers that you found in step 3 will go in the upper right and lower left corners of your box. And then finally, find the greatest common factor of each row and column. Write these values on the top and left side of your box. These expressions that represent the width and length of your rectangular box are the factors of your quadratic expression. Let's look at a few examples. First, we want to look for the greatest common factor. In this problem, 2 is the greatest common factor. So I want to factor out a 2. Now a is equal to 1, b is equal to 12, and c is equal to 35. My next step is to multiply a and c to get 35. I need to find two numbers that multiply to get 35 and add to get 12. To do this, I'm going to make an organized list of the factors of 35. 1 plus 35 is 36. 5 plus 7 is 12. This means that the two numbers that I am looking for are 5 and 7. I'm going to substitute those two values into my equation for b. Since this video is demonstrating how to use the box method to factor, let's go ahead and set up our box. Once all four values are in the box, I need to find the greatest common factor of each row and column. The greatest common factor between x squared and 7x is x. The greatest common factor between 5x and 35 is 5. The greatest common factor between x squared and 5x is x. And the greatest common factor between 7x and 35 is 7. Now that I have my factors for my rectangular box, I can use them to write my quadratic expression in factored form. Also, make sure that you notice that the 2, which was the greatest common factor of my original expression, is included in the factored form of the expression. It's important to make sure that your final factored expression is equivalent to the original expression given in standard form. In this example, the GCF is equal to 1, so we don't need to start by factoring something out of all three terms. This means that our first step is to multiply a and c together. For this problem, we need to find two numbers that have a product of 30 and a sum of 17. I again start by making an organized list of the factors of 30 and find the sum of each pair of factors. 2 and 15 are the numbers I'm looking for. So I use them to rewrite my expression by replacing 17x with 2x plus 15x. Now I'm ready to fill in my box. And then find the greatest common factor of each row and column of my box. Once I have my factors from the top and left side of my box, I use them to write my quadratic expression in factored form. This example can be completed by following the same steps, but it is also an example of a special case called a perfect square trinomial. A perfect square trinomial literally makes a perfect square when you model it with a rectangular area model. If we look at the steps for factoring, we can see why this happens. The GCF is 1, so we can move on to finding the product of AC. When we find the two numbers that multiply to get 100 and add to get negative 20, we find that they are the same numbers, negative 10 and negative 10. Then we use those two numbers to rewrite our expression and fill out our box. The whole box is not only a rectangle, but it's also a square. Since the factors are the same, we can write the factored form of the equation as a perfect square binomial. These types of equations should remind you of your work from earlier in this unit when you completed the square. This special case of factoring a quadratic expression is called a difference of squares. With these expressions, you're subtracting one perfect square from another one. We can follow the same steps for factoring to discover the pattern that will appear in these types of expressions. In this problem, the GCF is 1, so I do not need to worry about factoring out a greatest common factor. To make this expression look similar to the other ones that we have done, I'm going to rewrite it as x squared plus 0x plus negative 49. Since there wasn't a value for b listed, there was only a value for a and c in my original expression. I know b is equal to 0. Once I multiply a and c together, I can see that I need to find two numbers that have a product of negative 49 and a sum equal to 0. To get a sum equal to 0, I need one value to be positive and the other to be negative. As I'm listing the factors of 49, I think about the fact that the square root of 49 is 7. 7 plus negative 7 will equal 0, and 7 times negative 7 will equal negative 49. This will happen with problems like this, where you can take the square root of the product of AC to find your two numbers that will add together to make 0. We can now continue to follow our steps for factoring and write our expression in factored form. Even if there are special cases, these steps will work for factoring all quadratic expressions. First, look for a greatest common factor. If there is a greatest common factor other than 1, factor out your greatest common factor. Then multiply a times c and find two numbers that multiply to get the product AC and add together to get a sum equal to b. The two numbers that you will find will be used to replace b in your expression. Now fill out your box. The two numbers that you found in step 3 will go in the upper right and lower left corners of your box. And then finally, find the greatest common factor of each row and column. Write these values on the top and left side of your box. These expressions that represent the width and length of your box are the factors of your quadratic expression. All right, that's it for this video. Thank you for watching.